तो पहले इस पेपर से, ठीक है, W22 क्वेश्चन पेपर।
सलाम सर।
वालेकुम, हाँ जी।
सर एक सवाल है, पहले हम स्टार्ट करें उससे पहले
ठीक है।
कि हम लोग ट्रांजिशन एलिमेंट्स में जब बनाते हैं उनकी ज्योमेट्री, तो जब कॉपर के साथ फॉर एग्जांपल 4 क्लोरीन लगे होते हैं तो वो उसकी टेट्राहीड्रल होती है।
हाँ
लेकिन वो अगर वो पीटी, वो जो कैंसर वाला बाइंडिंग, वो जो होता है प्लैटिन मेरा ख्याल है, उसके
हाँ।
साथ जब 4 बॉन्ड होते हैं तो उसकी ज्योमेट्री डिफरेंट होती है, उसकी स्क्वायर प्लानर होती है। तो इसकी क्या वजह है, और हमें हाउ डू वी फिगर आउट कि किसकी क्या ज्योमेट्री होगी?
अच्छा, पहली चीज है कि उसके ऊपर ना वो पूछेंगे नहीं, ठीक है, they're not going to ask you कि उसकी ज्योमेट्री डिफरेंट क्यों है। लेकिन जो मेन रीजन है ना अबाउट व्हाई ज्योमेट्रीज आर डिफरेंट, ठीक है, दैट डिपेंड्स ऑन द रेशियो ऑफ द साइजेस ऑफ द आयंस। ठीक है, आयोनिक लैटिसेस के अंदर भी ज्योमेट्री डिफरेंट होती है कि हाउ मेनी आयंस लिगेंड्स कैन यू पैक अराउंड अ मेटल आयन। ठीक है, अगर छोटे होंगे ना स्मॉलर आयंस, तो यू कैन पैक मोर ऑफ देम, सो यू कुड पैक 6 ऑफ देम। ठीक है, आइडिया क्लियर है?
हाँ जी।
तो अगर वो लिगेंड का साइज जो है ना दैट्स बिगर, ठीक है, फॉर एग्जांपल वो कॉपर के देख लेते हैं। सो ये वाला, तो इफ द लिगेंड साइज लाइक वाटर इज 18, राइट? सो वाटर इज 18, एक सेकंड, वाटर हैज एन एमआर ऑफ 18, the water is slightly smaller, ठीक है, NH3 is 17, so that is also small, so you can pack 6 of them. लेकिन if you have a bigger ligand like ClCl, उसकी MR AR क्या है, that's 35, एक सेकंड, सॉरी फिर मैं मिस हो गया, so Cl is 35, right? So that's a bigger ligand, so you can just pack 4 of them around it, ठीक है, so you just have to remember this, ठीक है, they're not going to ask you about why they have different geometries, लेकिन reason समझ आइए why are they different?
हाँ जी सर, मेरा जो बेसिक सवाल था वो ये था कि वो जो हमने कौन सा याद करना है कि जिसमें वो स्क्वायर प्लानर होगा, वो हमें कुछ स्पेसिफिक याद है इसमें?
Specifically ना, ये जो notes है ना, everything that's written in the notes, ठीक है,
हाँ
that's
जी।
all you have to remember, ठीक है। For example, for copper you have to remember all of them. Copper with water octahedral, copper with NH3 that's octahedral, copper with Cl that looks like this, ठीक है, copper with OH is also, वो तो खैर it forms a precipitate. Cobalt has exactly the same shapes, ठीक है,
हाँ जी।
everything is exactly the same shape, only the colors are different. बाकी रह गया the other one, cisplatin, you have to remember cis and trans. Where's cis and trans? Just one second. ये वाला cis and trans, you have to remember this specific shape, square planar, just these two shapes, that's it.
यानी स्क्वायर प्लानर इसके अलावा कोई नहीं आएगा?
नहीं, like if there is square planar, I remember there was one question, ठीक है, and in that question they stated कि there was, मतलब वो इसी तरह ना, it had 4 ligands, right? So you had to figure out whether it was tetrahedral or whether it was square planar. So they told us that, they told in the question that it was forming cis and trans isomers. So
सही
tetrahedral
है।
does not have cis and trans isomers. इसके अंदर
सही।
this one has square planar, has cis and trans isomers. So there was
ठीक
just
है।
this one tricky question. Otherwise, the questions are usually very, very straightforward. ठीक है?
ठीक है। और एक और छोटी सी चीज है इसमें कि जब हमने वो बाइडेंटेट लाइगेंड लगता है तो तब भी सेस एंड ट्रांस एग्जिस्ट कर सकते हैं?
हाँ, वो मैं शो कर देता हूँ, just one second. अच्छा, तो bidentate, मतलब overall go through करें, bidentate is sorry, cis and trans is that the it could happen in square planar shapes, ठीक है, you've got cis and you've got trans, opposite sides. Octahedral, this is cis, this is opposite sides, that's trans. This is not called cis and trans अगर वो 3 ligands है, but it's still something that's similar to it, ठीक है, this is one arrangement, this is if 2 of them are opposite to each other. Then you have bidentate ligands. If you have bidentate ligands and there are 2 monodentate ligands, the monodentate ligands could be together or they could be on opposite sides. So this is your cis and this is your trans. ठीक है?
सही है।
तो उसके अंदर भी होगा। ये क्लियर? और तो कोई क्वेश्चन नहीं है?
सर इसमें
नहीं।
एंटी कैंसर का भी बता दें।
एंटी कैंसर
जी सर।
वो सिर्फ था कि you just have to really remember this fact that your cisplatin is anti-cancer because it prevents cell replication. So if you have a cancer cell, so what happens is that the DNA has bases. You don't basically know the structure of DNA, so they're not going to ask you about this in detail. The only thing is that the nitrogen bases, they bind with the platinum. So the ammonia ligands, they get replaced by the N bases in the DNA polymer chain. So the DNA is unable to split or unzip or replicate. That's it. Just in the most general way possible. ठीक है? नहीं जो P5 हम बाद में करेंगे अभी P4. Let's stick to P4. So ठीक है ये वाला paper, this one. ये कौन सा? This is W22 question paper 4.3. Sorry, खुल गया. 1 second. 4.2.
अच्छा सर, ऑप्टिकल स्क्वायर प्लानर नहीं बना सकता ना?
ऑप्टिकल नहीं, फॉर स्क्वायर प्लेनर नहीं. ठीक है, स्क्वायर प्लेनर डज नॉट फॉर्म ऑप्टिकल. ऑप्टिकल के अंदर यू नीड किधर क्या ट्रांजिशन. ऑप्टिकल के अंदर यू नीड octahedral shapes. ठीक है, ऑप्टिकल will be formed in 2 scenarios. Either you have 3 bidentate ligands in an octahedral arrangement, ठीक है, that's going to form mirrored versions, and the other one is हाँ फातिह वो मुझे पेपर बता दो, उसके प्रॉब्लम्स बता दो. ठीक है, ये लुबना वाला करके उसके बाद कर लेते हैं. अच्छा, octahedral would be formed when you have 3 bidentate ligands. There's going to be a mirrored version. ठीक है, or you could have 2 bidentate ligands but you have 2 monodentate, but they should be together, not opposite to each other. ठीक है, so even then it's going to have mirrored version. That's the only 2 scenarios. Either 3 bidentate ligands or 2 bidentate with on 2 sides you have monodentate. ठीक है,
तो बेसिकली उसमें सिर्फ मोनोडेंटेट लाइगेंड हम उसको मिरर कर रहे हैं ना?
किसको?
सिर्फ हम मोनोडेंटेट लाइगेंड्स को आपस में
पूरा मिरर कर नहीं, पूरा मिरर कर रहे हो.
अच्छा सही है.
ये वाला part, this is getting mirrored. ठीक है, this part is on the left side, that is on the right side. The CLs are मतलब pointing this way, now they're pointing that way, so everything has to be mirrored. ठीक है,
चले सही.
जो tetrahedral will form isomers, लेकिन for that you would have to have all 4 ligands to be different, which is not usually the case. वो organic chemistry वाला ना कि like carbon can be chiral but all 4 groups have to be different. So normally in transition metals you don't have all 4 being different. मेरे से कोई खास uses नहीं होते. The only problem is that I mean the only discussion about optical isomers, enantiomers, या geometric isomers or stereoisomers is that if you're trying to make this molecule, you might end up making this molecule as well. One of them will work because of stereochemistry, because reactions are very shape specific. So one of them will be working properly, the other one might not be able to. This is anti-cancer drug, because of the shapes, where's the anti-cancer drug? Cisplatin works. Transplatin is not able to work. Because the NH3s that need to be replaced will be on opposite sides. So wo jo DNA chain will not bind properly. तो stereochemistry का सिर्फ वही है. बस ये स्टार्ट करें. एक से ये पहले पेपर कर लेते हैं. लुबना कौन सा स्पेसिफिक क्वेश्चन है?
Sir, question number 2.
So let's start with question number 2. ठीक है, this is क्या है? W22 question paper 4.2. As a question number 2 is you have to, the reaction is first order with respect to NO. Second. As a reaction is first order with respect to NO, complete the rate equation for the reaction. The rate constant is given, everything is given. So that's 11,500 rate constant times NO concentration, O3 concentration, and it's first order with respect to both of them. Okay, that's what it's saying. Then he says the reaction is carried out in which the initial concentration of NO and O3 are both 1.2 times 10 power minus 6. calculate the initial rate of this reaction, state its units. So just plug in the values here. 11,500 multiplied by both concentrations are 1.2 times 10 power minus 6. So what do you get for this? क्या आंसर है? And the unit as well, mole per dm cube per second.
1.65 times 10 to the power minus 8.
So what are your, ठीक है, 1.65 times 10 power minus 8. What are your units? The units for K are mole minus 1, dm 3, S minus 1. The unit for concentration was mole per dm cube.
सर हम कंप्लीट पेपर नहीं कर रहे.
So ये पूरा कंप्लीट कर लेते हैं.
तो सर फर्स्ट क्वेश्चन स्किप हो गया क्या?
वो इसके बाद कर लेते हैं.
ठीक है.
अच्छा, मोल per dm cube into mole per dm cube. तो mole minus 1, dm 3, S minus 1. So what is the units? अच्छा, वैसे by default rate of reaction का जो unit होता है, that's going to be mole per dm cube per second. But it's concentration per second. Okay, you can figure that out over here as well. Okay, mole minus 1, mole gets cancelled out, dm3, dm minus 3 gets cancelled out, and that's what you're going to get. Okay. Now the next part is the reaction described in A2 is monitored over a period of time. Predict whether or not the graph of NO gas time under these conditions shows that the reaction has a constant half-life. Explain your answer. The reaction described in A2 is monitored over a period of time. To predict whether or not, अच्छा, अब बताओ कि it's monitored over a period of time. Will it have a constant half-life? Because it is first order, right? First order की half-life क्या होती है? What's the half-life for a first order reaction?
So it's constant.
सर कांस्टेंट होगी नहीं.
हाँ, नहीं होगी. क्यों नहीं होगी?
क्योंकि उसकी वजह से दोनों इसमें अपना इनपुट डाल रहे हैं. तो
हाँ, मैं बताता हूँ कि overall जो है ना, it's actually order 2. Overall, क्योंकि it's first order with respect to both of them, ठीक है? So if it's first order with respect to both of them, then overall it's order 2. And the problem is that both of them have equal concentration. So if the concentration of this decreases, the reaction slows down. But at the same time, the concentration of O3 is also decreasing. So that means the reaction slows down again. The first order of a first order, so that basically overall it's second order. So if somebody predict or whether, so it's not, it's not going to be constant. Why? Because overall, the overall order is 2. So that's why it's not going to be constant. Constant tab hota tha if you were investigating one of them and you're keeping the other one in excess. Excess mein dal ke na, you were trying to keep the concentration of the other reactant as constant, which you're not doing over here. Okay, dono ki concentration, both of them have equal concentration. So if one decreases, the other one would also decrease, and hence it's going to be order 2. Okay, is this clear? You clear enough? It's not going to be order 1. Huh?
Clear.
अच्छा, फिर अगला part के nitrous oxide decomposes into its elements at high temperature. Small amount of platinum wire is added to that's catalyst. So a large amount of nitrous oxide gets produced. Amount Y is added. The reaction follows zero order kinetics. The platinum wire behaves as a catalyst. So it's following a zero order kinetics. Sketch a graph on the axis. So if you have a zero order kinetic, or a zero order, if you have a zero order reaction, how would the graph look like for rate versus time?
Constant.
Constant rate. It will not change. Zero order can the rate will remain exactly constant, because the change in concentration or anything, it's not going to affect the rate of reaction. So it's going to be constant. It's going to be a constant straight line. So Now again, it's the same zero order reaction. Now what he's saying is, on the axis below, sketch the concentration of N2O. N2O was your reactant. Let's go, if I could put this in the same. So N2O was your reactant. Remember, it was a zero order reaction. How would the concentration with respect to time vary with respect to time? How would that happen?
So it will decrease.
Concentration decrease, again, how would it decrease? Would it
Straight line.
it's going to be
Straight
a straight line because the rate is not changing, so the rate remains unaffected, it does not change. So the gradient of this graph is actually rate. So NO to the power 0 is basically constant. So it's going to be a constant straight line. Again, if it had been order 1, so how would the sketch look like if it was order 1? If it had been order 1, तो फिर constant half-life होती. That means के it's going to take every time for the concentration to decrease. It's going to be a curve in that case. The reaction will continue to slow down. क्योंकि order 1 के अंदर the concentration decreases with respect to time. The rate would also decrease. But in this case, it's going to be a straight line. ये तो clear है ना? और अगर if it had been order 2 में क्या होता है? The half-life would double. So every time ये graphs भी थे एक से मैं दिखा देता हूँ. एक ही reaction kinetics A2 just 1 second. So make sure you know how these graphs work. 1 second. These are the graphs. ठीक है. So order 0 means the reaction speed does not change. ठीक है. The gradient does not change. Order 1 means constant half-life. Every time it's just going to slow down, but proportionally slow down. Order 2 means that it's going to slow down too much. If the concentration decreases, the half-life doubles. So it's going to take a much longer time for it to, for the concentration of the reactant to get used up. ठीक है, तो ये 3 graphs हैं. अच्छा, next one. Describe the mode of action of a heterogeneous catalyst. ठीक है. When you have a heterogeneous catalyst, तो क्या होता है? What are the 2 words that you're going to use for a heterogeneous catalyst?
Adsorption and deadsorption.
ठीक है, so you just have to explain adsorption. That's the यहाँ पे होगा एक second. नहीं, वो दूसरे वाले में एक second. So adsorption and deadsorption. Adsorption is that the reactant molecules are going to make weak bonds with the catalyst. And deadsorption is the weak bonds that are formed between the reactant molecules and catalyst, they would break. And now new bonds can be formed. So the catalyst weakens the old bonds. Now suggest a reason why this reaction has zero order kinetics when the amount of nitrous oxide is large and the amount of platinum is small. So why is it following zero order kinetics? जब क्या होता है when you add too much nitrous oxide, that's your reactant. When your reactant is in large excess,
Change in concentration is constant.
ठीक है, so when the reactant is in large excess, so in that case, its concentration is almost constant or hardly changes. So that means the concentration would not be changing. So that means the reaction speed will remain unaffected. अच्छा, 1 कर लेते पहले. अच्छा, lattice energy क्या है? It's the energy that is released when, what happens when 1 mole of ionic lattice is formed from what? From its gaseous ions. Use data in table 1.1 to calculate the standard enthalpy change of formation of. So इसके लिए you would have to make the complete Hess cycle, ठीक है, for calcium chloride. So calcium plus Cl2 enthalpy. Let's start with enthalpy of formation. So they're going to form what? Calcium chloride solid. So this is what you're looking for. This is what you want to find, enthalpy change of formation. So what happens? Okay, first thing, you're going to atomize it. एक ही step में कर लेते हैं, ठीक है? You atomize it. You form 2 Cl gaseous atoms. Then what do? You ionize them. Let's do all of that in one step. And once ions are formed, you form the lattice. So you form the lattice, right? So atomize calcium solid to calcium gas. How much energy is required? Is it given somewhere over here? Atomization of calcium, that's plus 190, 193. This is given plus 193. How do you turn Cl2 into 2 Cl atoms? Kya given? Is it given over here? They've given you the enthalpy change of atomization of Cl. That is 121. Like that's going to be 121 times 2 because you're forming 2 Cl atoms. So then you ionize calcium gas to calcium 2 plus. Compare. That's the first plus second ionization energy of calcium. So that's 590 plus 1150. मैं देख लेता हूँ, उसका तो देख लेता हूँ पिछले पार्ट का.
Yeah, sir.
एक second. Why this reaction has zero order when the amount of nitrous oxide is in large excess? Is large and the amount of platinum is small.
सर वो फिर एक्टिव साइड जो उसकी साइड होती है उस पे कम लगेंगे ना.
हाँ, उसमें मार्क्स स्कीम में ये लिखा हुआ है. तो क्वेश्चन ये था, ये गलत है, ये वाला पार्ट हमारा गलत है. So what the marking scheme is describing is that the catalyst is small and there's too much nitrous oxide. So basically, there's not enough platinum to actually catalyze the whole reaction. So the reaction basically kind of becomes independent of the catalyst. Okay, so the reaction speed does not change because there's too much nitrous oxide. तो excess वाली बात नहीं होगी कि हाँ नहीं, फिर ये तो गलत है क्योंकि it's got nothing to do with what he's saying. So all the active sites of the platinum is fully used up. There's not enough platinum to actually catalyze the entire reaction. So which is why it's following zero order kinetics because the reaction is not able to kind of change its speed because there's not enough catalyst to go around. ठीक है, वो ये explain कर रहा है. ठीक है, लेकिन पता नहीं, that's still too far-fetched, I guess. Because somebody would, okay, it's 1 mark, but keep this in mind. Like if you get a question like this related to a catalyst, if you're using too little catalyst, there wouldn't be enough active sites and the catalyst would not be able to catalyze the entire reaction. So वापस next part उसका solve कर लेते हैं quickly के कहाँ पे पहुंचे थे. अच्छा, electron affinity of Cl minus 364. बस minus 364 times 2. अच्छा, whenever you're making bond cycles, make sure that there's a very bright chance that you might get it wrong. Try to check the moles everywhere. Okay? And finally, you have the lattice getting formed. What is the lattice energy of that's minus 2237? And be very careful with the calculator as well. Okay? So this is your one path and that's your other path. Okay? So you just add up all of them. So x is basically equal to what? It's equal to plus 193. plus 121 times 2. Okay, plus 590 plus 1150. Minus 364 times 2. And minus 2237. इसका क्या आ रहा है? What are we getting for this?
minus 790.
Minus
790.
ठीक है, ये कोई चेक करता है ठीक है कि ये सही है कि नहीं. So this one is minus 790 if you did all the calculations correctly. So I guess ठीक है. As a next part, 3 possible values for the first electron affinity of bromine are shown. One of them is correct. Place a tick. So as I remember about electron affinities, place a tick by the correct values. Will bromine have? Who's going to have fluorine, chlorine, bromine, iodine? Okay. It's kind of you need to know the trends in electron affinities. Do they increase down the group or do they decrease down the group?
Decrease.
Okay. Except for there's an exception for fluorine. The graph probably kind of looks like this, that fluorine is somewhere over here and then the rest. Okay, so the electron affinities decrease. Chlorine likes to gain electrons, bromine does not really like to because it's more shielded. Okay. And iodine is even more shielded. It's got more electrons, so it's got an even lower tendency to actually attract electrons. So the energy released when iodine is attracting electrons is very less. So it's going to decrease. Pehli wali kya thi? It was minus 342. For chlorine, it was minus 364. So bromine ki isse kam hogi. Bromine is going to be minus 342. And the explanation for that is that bromine would be more shielded. Or you can have more shells. That would result in less attraction for.
Sir, what does the minus sign stand for?
Electron affinities exothermic hoti hai na? The first one. I mean, like lattice energies are all exothermic. Electron affinities, the first one, all of them are exothermic. Because when electron gain karta hai, it releases energy. Because it attracts the electron, does all the work itself. No external energy is required for that. So the first electron affinity is always exothermic. Problem aata hai when you have the second electron affinity, then the electrons are not automatically gained. The work is not done by the atom because the problem is that now you've got a negative ion attracting an electron and there's repulsion. So the electron, you have to give the electron energy so that it can overcome the force of repulsion and enter the shell of an oxygen ion. Is that clear?
Sir?
Haji.
Sir, lower value का मतलब है कि higher energy. जैसे मैथ्स में होता है -1 -2.
नहीं, इसमें lower का मतलब है कि it's less exothermic. Use the word less exothermic.
तो सर मतलब कि हम जब नीचे जा रहे हैं ट्रेंड जब फॉलो कर रहे हैं तो उससे एनर्जी ज्यादा रिक्वायर है तो वैल्यू हमें ग्रेटर नहीं चाहिए होगी फिर.
नहीं, एनर्जी, ये मैं एनर्जी की वैल्यू बता रहा हूँ. साइन का मतलब है रिलीज या एब्जॉर्ब. इसमें एनर्जी के अंदर रिमेंबर कि इट्स नॉट, ये मैथ वाला साइन नहीं है. मतलब मैथ, फॉर एग्जांपल ओवर हियर इन केमिस्ट्री यू हैव गॉट -20 joules, you've got +20 joules. ठीक है, एनर्जी वाइज दे आर एग्जैक्टली द सेम वैल्यूज. ठीक है, माइनस एंड प्लस रिप्रेजेंट्स डायरेक्शन.
सर अगर उसको ज्यादा एनर्जी रिक्वायर होगी तो फिर हम
कम चाहिए ना.
पॉसिबल वैल्यूज में फिर ग्रेटर लेना चाहिए.
इसको कम एनर्जी चाहिए.
सर ब्रोमीन फ्लोरीन वाले में.
हाँ, तो उसकी जो एनर्जी की वैल्यू है दैट डिक्रीजेस डाउन द ग्रुप. साइन को छोड़ दो, साइन को छोड़ दो, साइन को बिल्कुल इग्नोर करो. साइन जो है वो डायरेक्शन है. ठीक है, all first electron affinities are exothermic. ठीक है, साइन इज डायरेक्शन. सिर्फ क्या है कि ब्रोमीन इज गोइंग टू रिलीज लेस एनर्जी. कम है उसकी वैल्यू. आयोडीन इज गोइंग टू रिलीज इवन लेस एनर्जी. तो अगर दिस वाज 364 क्लोरीन, ये क्लोरीन है. If Cl was 364, bromine, the energy that bromine will release is going to be lesser. So it's going to be 342. Iodine would be even lesser. जो भी है, whatever iodine is, let's say it's 315. Iodine would be even lesser. Minus तो उसका sign है ना, that energy is going to be released.
सर इलेक्ट्रॉन को हम इंसर्ट करेंगे तो एनर्जी रिलीज होगी.
हाँ, क्योंकि वो खुद ही सारा वर्क डन खुद ही कर रहा है ना. क्लोरीन इलेक्ट्रॉन गेन करता है ना, तो you don't have to do anything. Chlorine will do all the work on its own. जैसा क्लोरीन है ना, उसको सोडियम के पास छोड़ दो, ठीक है. तो आप तो कुछ नहीं कर रहे ना, आप chlorine will pull the electron out of sodium, will do all the work on its own. So you're not giving it any energy. ठीक है, chlorine is very reactive. It is reactive because it's able to do that. It's got a nucleus that attracts electrons and pulls electrons from other atoms, does all the work on its own. So that means it does work on its own. So it produces work. तो इसलिए वो exothermic है.
ठीक है.
मतलब किसी भी पॉइंट में आपने उसको एनर्जी नहीं दी. हाँ, सेकंड वाले के अंदर ना you would have to give it energy, because if it's the second electron affinity, then it's a negative ion. If it's a negative ion, the electron is not going to be attracted automatically because it will be repelled. So आप क्या करोगे? You will make the electron give it kinetic energy so that it comes sufficiently close to the nucleus of oxygen -1. It has to overcome the repulsion. So इसके अंदर ना you would have to give it kinetic energy. You would have to make it energetic. Is that clear?
Yes, sir.
तो मैं फिर से summarize कर लेता हूँ, ठीक है. The negative positive को छोड़ो. Just remember that down the group, the electron affinities become less exothermic. ठीक है. So they become less in value. Why do they become less in value? Because the attraction for electrons decreases. Fluorine is an exception. Fluorine की electron affinity क्यों इतनी कम है?
छोटा है,
क्योंकि
small
वो
है.
नहीं, it's very small and it's got very high charge density lone pairs. तो fluorine के केस में the problem is that fluorine is such a small atom that the electron is no longer automatically attracted to it. वो उल्टा क्या होता है? वो repel होता है. I mean, there is some repulsion. So the fluorine is not able to actually pull the electron that strongly. So fluorine is an exception. कि fluorine की bonding में भी था कि fluorine का bond जो होता है it's slightly weaker. अच्छा, okay, next part. The enthalpy change of hydration of chloride. ये clear है ना बात?
जी सर.
अच्छा, फिर next part. The enthalpy change of hydration of the enthalpy change of solution of CaCl2 is एक second. The enthalpy change of hydration of the chloride ion can be calculated using lattice energy of calcium chloride and data shown in a table. So define the following terms. Enthalpy change of solution क्या होता है? It's the energy released or absorbed when 1 mole of a solid ionic lattice, 1 mole of solute is completely dissolved in water to form an aqueous solution. What is enthalpy change of hydration? If I write an equation for this, it will be CaCl2 solid turning aqueous. So 1 mole of solute completely dissolves in water to form an aqueous solution. So what is enthalpy change of hydration? It is when a gaseous ion, like calcium ions, gaseous. So 1 mole of gaseous ions are completely surrounded by water molecules to form 1 mole of aqueous ions. So it's the energy release. This is always exothermic. It's always exo. Solution is exo. It could be endo as well. Solution दोनों हो सकते हैं. So calculate the enthalpy change of hydration of chloride ions. It may be helpful to draw an energy cycle. So ये lattice energy, enthalpy of solution की energy cycle है. What happens is that when you dissolve calcium chloride in water, it dissociates into its aqueous ions. The value for enthalpy of solution is given. That's -83. They've given us this value. Now, when you dissolve something, you do two things. First thing is you break the lattice. When you break the lattice, you get gaseous ions, calcium +2 gaseous ions and 2Cl -1 gaseous ions. Okay, that's breaking the lattice. So how do you break the lattice? Uske liye you need lattice energy. So the lattice energy is, I think it was given in the previous page. Kahan pe given a lattice energy? It's given over here. Minus 2237. So the first part is ki you're going to break this lattice, minus 22. Then once you have the gaseous signs, you turn them into aqua signs. So that is enthalpy change of hydration. So iske andar they've given you the enthalpy change of hydration of calcium ions, that's minus 1650. But they did not give you the enthalpy change of hydration of Cl ions. वो क्या होगा? That's x times 2 हो जाएगा क्योंकि there are 2 Cl ions. और बाकी वही है कि one path is equal to the other path. So one path, that's your other path. So remember this, कि the enthalpy change of solution is, इसमें वो मैं change करता हूँ, और बल्कि important है वो change करना था, because this is, you're breaking the lattice, so it's positive, ठीक है? ये सही है, ठीक है? Whenever you break the lattice, the lattice energy was this way, you're going in the opposite direction. So one path is equal to the other path, so minus 83 is basically equal to what? Breaking the lattice, that's 2237. Then hydrating the gaseous ions, so okay, that's minus 1650 plus 2x. इसका आंसर बता दोगे क्या आ रहा है? X, what is x?
minus 790.
This is 790 आ गया. पिछला 790 था, that's, I suppose minus 790 है. Are you sure this
No,
is the answer?
sorry, minus 335, sorry.
कितना minus?
335.
That's a minus 335. So next one, enthalpy of the value of enthalpy of formation is this. Predict the sign of entropy change for this synthesis. Explain your answer directly from its elements. So calcium solid plus fluorine gas. So elements CaF2 solid. Okay, entropy change sign. What is it? Negative or positive?
Negative.
Negative.
Okay. And why? Because why?
Decrease in gas.
Okay, decrease in gas moles. Your gas moles are decreasing, that's why it's negative. Use the value of delta HF given in E and your answer to predict how the feasibility of the synthesis will change with increasing temperature. So delta G is equal to what? Delta H minus T times delta S, right? So first thing, delta H is given, that's minus any negative. So this value is negative. Delta S, you also stated that it's negative. So it's negative value minus T times a negative value. So ek end jo hoga na, that will become positive. The negative signs will cancel out. Ab mujhe batao ki if I increase temperature, what will happen to the value of delta G? Will it become more positive, more negative?
More positive.
So if you have a large T, the positive side will be bigger compared to your negative side. So that means overall, so higher temperature, what happens? Minus T delta S becomes more positive. And because of that, hence delta G becomes more positive. So feasible or not feasible?
Not feasible.
ठीक है, delta G positive होता है, that means energy is needed from outside. ठीक है, so that means it's not, or it's going to be less feasible. So feasibility decreases, okay, as T increases. The feasibility of the reaction, it decreases. अच्छा, ये वाला कर लिया था, question C पे चलते हैं.
Sir,
हाँ जी.
I wanted to ask you a question. For example, the electrodes in electrolysis. For example, if we have like a Fe3 plus and Fe2, will we use a platinum electrode or an Fe electrode, like an iron electrode?
No, you're going to use a metal electrode only if there's a metal, like a metal, not its ions, a metal is involved in the reaction. If the metal is not involved, you're always going to use a platinum electrode. So if you have an FeC plus Fe2 plus electrode, you're going to use a platinum electrode because you don't have Fe in the reaction. Is that clear?
Oh, okay.
So you're going to use a platinum electrode always, except when there is a metal in its neutral state that is involved in the reaction. Okay?
Okay, got it.
As a defined standard electrode potential, what is that? It's usme details bhi hota hai. So standard electrode potential is what? It's a potential difference between a standard electrode and a standard hydrogen electrode, measured under standard conditions. You can quote the standard conditions, which are what? 1 mole per dm cube. Solution, 1 atmosphere pressure is for gas, and 298 kelvins is the temperature used. This is ye wala hai, theek hai? This one, ye example. Now over here he's talking about an Mg2 plus electrode. Just 1 second. Sorry, completed diagram. So yeah, Mg2 plus electrode. Now if Mg is involved, so you're going to use an Mg electrode, and the Mg2 plus would be part of the solution. Or दूसरे वाले में it's MnO4 minus Mn2 plus, right? So in that case, the ions will be part of the solution. Or मेरे ख्याल से there's H plus 1 as well, because they gave you the reaction at the top. क्या था MnO4 Mn2 plus? It's this one, right? And we've got an Mg2 plus electrode. It's this one. So now you're going to use a platinum electrode over here. You can attach a voltmeter and add a salt bridge. ठीक है? So as a player, use a positive and negative sign, so you can Mg2 plus electrode. The value for Mg2 plus is what? Minus 2.38. So this side is minus 2.38. The other side is what? 1.52. So obviously, this is your positive side, and that's your negative side. Higher potential is positive, negative side is the lower potential. Electrons would flow. किस direction में flow करेंगे electrons?
Negative to positive.
ठीक है, so it's going to go. It's going to go negative to positive. ठीक है, so that's the direction of electron flow. और फिर ये कि calculate the cell potential of this cell. So वो तो reduction potential minus oxidation potential, or higher minus lower 1.52 minus 2.38. तो वो जो भी वैल्यू आ रही है लिख दो यहाँ पे, ठीक है? minus 2.38 और minus plus हो जाएगा. It's minus 2.38. So that will become plus. I said then you have the next part is considering an equation for the cell reaction. So the higher potential gains electrons. This is the one that's going to gain electron. That's the one that's going to lose electrons. You have to make the number of electrons equal first. So this has to be multiplied by what? 2, and this has to be multiplied by kitna hoga? 5. So it's going to be add up the two equations. So it's going to be 2MnO4 minus 1 and 16H plus 1. What are the reactant on the other side? That's 5Mg. What are your products? 2Mn2 plus 8H2O. What is the product on the other side? That's 5Mg2 plus. So you have a reaction, overall reaction, for this particular case. Now consider the equation for the cell. We did that. Predict how the cell reaction will change if at all when the solution of Mg2 plus Mg half cell. अच्छा dilute करोगे तो where will the equilibrium shift? ये वाला forward or backward?
Backward.
ठीक है क्योंकि concentration कम होगी ना, so aqueous ions it's going to get diluted, and if it gets diluted, equilibrium will shift backwards. If it shifts backwards, what happens to the potential?
Increases more.
ठीक है, it's going to decrease even more. So अपनी तरफ से let's say it becomes minus 2.50, right? So always remember that if the equilibrium shifts in any particular direction, specifically if it shifts in the backward direction, the potential will decrease. If it shifts in the forward direction, the potential over here will increase. Okay. So over here in this case, he's diluting it, so the concentration will decrease and it will shift backwards. So the potential decreases further. So what happens to the potential difference? वो ज़्यादा हो जाता है ना? The E0 cell increases, right? And if your E0 cell increases, that means the reaction becomes more feasible and you're going to get a faster reaction. So इस part का वही answer है कि consider an equation for the cell reaction. नहीं, sorry, ये वाला. तो उसका you'll first quote this thing that the Mg2 plus Mg electrode equilibrium will shift backwards. So you're going to state that it shifts backwards. Potential will decrease, and which is why the overall cell potential would increase. The difference will be higher. फिर अगला part, और remember ये याद रखना कि remember this simple part, which is if according to Lee-Shatler principle the equilibrium is shifting backwards, potential will decrease. If according to Lee-Shatler principle the equilibrium is shifting forwards, the potential will increase. अच्छा, अब अगला part के molten magnesium salt is electrolyzed for 15 minutes by constant current. Magnesium atoms are produced. Calculate the value of the current. So how would you do that? So उसमें क्या करना है? उसमें आपके पास Mg2 plus है. 15 minutes time is given. So he's asking for the value of current. Now I've got magnesium atoms. First thing I can just turn them into moles. कितने moles आ रहे हैं? Divide this by 10^23. So how many moles do you get? किसी के 4.7?
0.0789.
अच्छा, 0.0789 moles. ठीक है. Magnesium atoms, right? 0.0789 moles. So electrons के moles कितने होंगे? That's going to be double that. So what is that? What's double of this?
0.158.
अच्छा 1 mole of electrons पे क्या charge होता है? That's 96,500 coulombs. तो 0.158 moles पे क्या charge होगा? That's going to be x multiply कर लो 96,500 multiplied by 0.158. What do you get?
15228.
15228 is the charge coulombs that is flowing through the circuit. Q is equal to IT. You know the time, that's 15 minutes. Every minute has 60 seconds. So find out the current.
$16.9.
He gets a 16.9 amperes. Okay, probably I think that's fine. So you're getting 16.9 amperes. So ठीक है, ये question भी हो गया. अच्छा, quickly, भैया questions बता दो. कौन से questions थे? First paper.
Sir, March 23.
March 23. एक second. वो पता नहीं गुम हो गया मेरे से एक second अपना. March 23, right? It's March 23, 522. मिल गया. Alicia, उस part में कि we already did it to, I mean, I did multiply the electrons by 2. So that's the moles of electrons, right? 0.152. So I know that 1 mole of electron carries this much charge. I have these many moles of electrons. So how much charge would they have? So I don't get कि 2 दफा 2 से क्यों multiply करना है? अच्छा, so ये paper खुल गया, March 23. 4.2 once again. हाँ, इस पे कौन सा question है?
Sir, question number 2, C part 1.
So question number 2, C part 1. The volume of H2 measured in room conditions, use the molar volume of gas. To calculate the rate of reaction in mole per dm cube. So use the molar volume of gas. Molar volume of gas, I think, that's your 24 dm cube. ये होता है molar volume. इस paper के end में मेरे ख्याल से the data is VM यहाँ पे लिखा है VM नहीं constants are given. हाँ नहीं अच्छा sorry, this is given you VM as molar volume of gas, वो दोनों दिए हैं 24 dm cube. Now I don't know which one he's asking us to use. Then probably you're going to use 24 dm cube. Is that clear? So if you go back to the question, the volume of H2. So rate क्या होता है? What is use molar volume and the data and calculate the rate of reaction. So पहले तो find out the moles. In 60 seconds, ठीक है? So he's given you what is rate? Rate is the change with respect to. So what is rate in experiment number 1? It's 6.4 cm cube per 60 seconds. Is that clear? So what you can do is you can convert the 6.4 cm cube into, divide that by 24,000. VM's 24,000. And how many moles do you get?
Sir, why divide by 24,000?
Moles कैसे निकालते हो?
Okay.
So how many moles do you get for H2 gas?
We have 0.67 into 10 to the power minus 4.
कितने moles आ रहे हैं?
2.67 into 10 to the power minus 4.
So you're getting this much, right? So you're getting this much mole, but he's saying mole per dm cube, right? ठीक है, ये थोड़ा tricky part है. We got the moles, but where do you get the dm cube? We got the seconds as well, right? So how do you get the dm cube part? So ये जो moles है इसी volume में है ना? I mean, basically, what do you have? You've got 2.67 times 10 power minus 4 moles in how many dm cube? In 6.4 cm cube, right? 6.4 divided by dm cube में क्या होगा? So is this clear that this is how you're going to put dm cube into the expression as well? Okay, you found the moles. Okay, इतने moles है 6.4 cm cube per 60 seconds, right? So you converted the cm cube to moles. Like he's asking us okay, mole per dm cube per second. So I'm going to bring in the dm cube as well. So how many dm cube was this? ये क्या आता है? How many dm cube is this? 6.4 divided by 1000. That's
6.4 into 10 to the power minus 3.
so 10 power minus 4 divided by dm cube कितना? That's 6.4 times 10 power minus 3. तो ये mole per dm cube हो गया. Divided by 60 seconds. Now I think you'll be able to get mole per dm cube per second.
.95 into 10 to the power minus 4.
इसकी मार्किंग स्कीम है इसकी. लेकिन इसी तरह होगा. But did you get the working? Okay, 6.4 cm cube of gas in 60 seconds. You have to convert it into mole per dm cube per second. So you convert this
Sir,
in.
Can you explain again?
नहीं वही इस ये volume of gas है ना, right?
Yes.
तो इसको आपने moles में convert कर दिया, right? वो आसान था,
Okay.
divided by 24,000, right? So you got 2.67 times 10 power minus 4 moles. But he didn't want moles. He wanted mole per dm cube, right? He wanted to know, okay, how much moles is this in what particular volume? तो ये जो moles है कितना volume में है? 6.4 cm cube में है, right? But we don't want cm cube. We want dm cube, right? So I divide that by 1000. Does that make sense? Because this is the mole per dm cube. I converted 6.4 cm cube of gas into mole per dm cube.
Okay.
Okay, इतने moles थे. Divide by the volume. The volume was already there. That's 6.4. So that's converted into dm cube. So you got mole per dm cube. And divide by 60 seconds at the bottom.
Sir, there's a different working in the mark scheme.
The answer क्या आ रहा है?
Answer भी different है.
उसकी snapshot भेजना जरा. 22.4 तो नहीं यूज कर रहा. भेज दिया.
Sir, भेजिए.
एक सेकेंड. ये तो उससे किया है 6.4 divided by 24,000, right?
Sir, उसने directly moles को divide कर दिया है.
उससे
Time
वही
से.
किया जो मैंने किया. नहीं मैंने नहीं.
Sir, आपने दोबारा से volume use किया था mole per dm cube करने के लिए.
नहीं मैं वही सोच रहा हूँ mole per dm cube, right? So you got moles मैं वो देख लूँ, एक सेकेंड, मैंने एक पार्ट एक्स्ट्रा किया हुआ है ना, मैं खाली वो देख लूँ कि अगर इफ यू कन्वर्ट इट इनटू मोल्स, इज दैट मोल per dm cube or not? 24,000, right? cm cube is 1 mole. So 6.4 cm cube, right? So that's how many moles? That's going to be more divided by 24,000 kind of. Okay, so you'll find that. So नहीं, उसका what he did does not make sense क्योंकि ये extra step करना पड़ेगा because that's not in 1 dm cube. मतलब ये बात समझ आ रही है? मुझे लगता है मार्क्स की वजह से गलत है, ठीक है, ये बात समझ आ रही है? ये जो एक्स्ट्रा स्टेप था ना डिवाइड बाय 6.4, ये करना मस्त था क्योंकि अदरवाइज यू वोंट गेट पर डीएम क्यूब, राइट? यू विल गेट द मोल्स, राइट? 6.4 डिवाइड बाय 1000, राइट? तो वो तो मोल्स आ गए.
So that's exactly why I was confused क्योंकि वरना
नहीं, वो डेफिनेटली मार्क्स स्कीम इधर ना वो गलत है, उसमें कभी बार गलतियां होती हैं उसमें, ठीक है, वो डेफिनेटली गलत है क्योंकि मोल्स तो आ गए, ठीक है, बट दैट मोल्स इज नॉट पर डीएम क्यूब, that moles is in 6.4 cm cube, it's not in a dm cube. Is that clear?
yes, okay.
तो मतलब वो फिर you can't write the unit mole per dm cube, right? तो आपको निकालने पड़ेंगे मोल्स के भी, आपको बताना पड़ेगा, वो फिर से कर लो ना कि it's 2.67 times 10 power minus 4 moles in but that's in 6.4 cm cube, right? तो अगर पर डीएम क्यूब निकालना है तो 1 डीएम क्यूब is 1000 cm cube, right? तो use ratios and find out what this is, ठीक है? तो तब आपके पास आ जाएंगे it's mole per dm cube और नीचे divide by 60 seconds. Is that clear? तो वो उसने डेफिनेटली वो एक स्टेप बीच में से ना मिस कर दिया वहां पे.
Okay, sir.
ठीक है, एंड मैं अब शेयर कर दूंगा, ठीक है, अभी मेरे पास आया होगा.
Sir, 3 part D1.
One, identify the
Yes,
vanadium
one.
species that forms ये वाला when excess of H2O2 reacts with V2 plus. Understand it, can explain your answer, right? So first thing, H2O2 is the higher potential, right? So what is the higher potential to it? There's only one reaction, the sun come here. Higher potential gains electrons, right? Is that clear?
Yes.
V2 plus is the lower potential. So what does it do? It
This is electron.
ठीक है, अब ये शायद वो वाला मसला है कि this is the chain reaction thing. अच्छा, V2 plus is the lower potential, right? It loses electrons. What is formed? V3 plus. अब V3 plus को देखो, it's still the lower potential. So compared to H2O2, it will again lose electrons. ठीक है, is that clear?
Sir, why?
देखो ना, chain reaction, V2 plus got converted into V3 plus, right? So now your solution contains V3 plus. Now look at V3 plus and this H2O2. The H2O2 is still the higher potential. So the H2O2 will oxidize, will reduce, and it will again oxidize V3 plus. वो इसके साथ भी react कर जाएगा. But higher क्या करता है? Higher gains electrons, right? What does the lower do? It loses electrons, right?
Sir, it's only because आपके पास H2O2 excess में है, right?
How specifically he wrote that's in excess. Even if it weren't in excess, even then it's going to be a chain reaction that it will continue on. The V3 plus that's formed will then further react with H2O2. It's still the higher potential, it will gain electrons, and the V3 plus would lose electrons. और फिर क्या बना? VO with a charge of 2 plus, right? And VO with a charge of 2 plus is still the lower potential, so it will again lose electrons. And it will form VO2 with a charge of plus 1. So basically it's 3 reactions, and you would have to, अब ये मसला, why is it just 1 mark? It's just, I mean, writing, is he asking you to write the equation?
No, he just...
अच्छा, फिर आसान है. So it's VO2 with a charge of plus 1, that's what's formed. ठीक है, and explain, so I'll just explain that V2 plus gets first oxidized to V3 plus. V3 plus जो भी है, equation 3 is still the lower potential, so it gets oxidized further to VO2 plus, which is still the lower potential, so it gets further oxidized to VO2 with a charge of +1. Is that clear?
So we simply write that H2O2 has the highest potential.
हाँ वो देख लो कि किस तरह से explain किया हुआ for 1 mark, right? वो
Okay.
ज़्यादा problem होता है if he asked you to make the final equation. Because then you would have to make 3 equations. First this one with this, then this one with the second one, the third one, then first with the second one. So there'll be 3 reactions. Then add up those 3 reactions and then you'll get your final reaction, the overall reaction. ठीक है? तो ये clear है?
Okay.
और कौन सा?
So 4A part 3.
Reaction also forms secondary and tertiary amine suggests the identity of a secondary or tertiary amine formed by the reaction of A2. A2, ethylamine is a product of the reaction of bromoethane with ammonia. Name the mechanism of this reaction and state the conditions used.
Nucleophilic substitution.
ठीक है, तो वो तो है. Ethylamine is this thing. It's NH2. So that's the product. When bromoethane reacts with ammonia. So H है H. Achha, so the carbon is positive, the Br is negative, and the NH3 will bring its lone pairs, ठीक है? And the Br is going to get repelled. तो एक तो ये हो गया. So Br is going to get repelled, and then you have उसके बाद क्या है? अच्छा, फिर वो क्या suggests? It says the reaction also forms secondary and tertiary amines. वो किस तरह होगा? The first amine will be formed. The Br is knocked out. Or NH3 बन गया. NH2, sorry. Is that clear? अब बताओ, how would a secondary amine get formed? Okay, there would be another bromoethane और जो ethylamine है ना, that will go and attack this carbon atom. So what you're going to get is कि एक तो पहले से N जोड़ा हुआ था, ठीक है? These were your H atoms. And now it's going to go and bond with that carbon, knock out bromine, and so this is what's going to happen. Is समझ आई बात?
Okay.
And then you'll have a tertiary amine as well. Okay, how would a tertiary amine form? There's going to be there's another bromoethane. This thing formed will go and attach to another. तो जो N है ना, वो जाके बार-बार जुड़ता रहेगा with bromoethane. So eventually that N will bond to पहले one ethyl got attached to one side of the N. Then that N still had a lone pair. It got attached to another bromoethane, then another one. Okay, so eventually it's going to get attached to 3 of them. Is this clear?
Sir, just specifically for this reaction, tertiary or secondary amines बन सकती है, right?
हाँ. कि वो lone pair तो वही है ना. It's still the same thing. So अब उससे क्या है कि वो बन रहा है. There's a secondary amine getting formed. So you just have to think, okay, how could that be possible? So that could be possible because you still have an amine, you have a lone pair, so that will get attached to another bromoethane. Okay, and then the product of the second one will get attached to another bromoethane.
So what do we write? Is it the secondary or tertiary that is formed?
नहीं, उससे तो क्या आइडेंटिटी बताओ ना कि क्या नाम है उसका. Yeah, write name करने को नहीं, just write it. So this is your secondary amine, and your tertiary amine is कि यहाँ पे भी ना there's going to be an ethyl group attached. तीसरी side पे भी. Is that clear?
Okay. 5C2. Okay.
ये 5 यही था।
4 था।
Draw the structure of an isomer of Q that forms an organic byproduct of the reaction. Step 2. Step 2. So acylation हो रही है ना? It's acylation where the C, this carbon positive over here, the C double bond OCl is getting attached, right?
Yes.
तो क्लोरीन कौन सा ग्रुप होता है? 24635
246.
246 होता है। तो अगर वो 2 पे अटैच है, it could get attached to the fourth side. मतलब the other isomer will be that this thing is attached over here. ठीक है, is this clear?
सर स्कीम में कुछ अजीब सा है। मार्क स्कीम
पढ़ लेते हैं एक बार फिर से।
उसमें कुछ अजीब सा आ रहा है।
Draw the structure of an isomer of Q that forms as an organic isomer of Q. तो यही होगा, और क्या होगा इसके? वो देख लेते हैं एक सेकेंड। Cl specifically, Cl जाके अटैच हो रहा है।
नहीं सर, it's on the position 4, 3 and 4 I think.
नहीं, मैं खोल लेते हैं इसे, डाउनलोड कर लूँ मार्क्स। फाइव का सी तो उसे 4 सब्स्टिट्यूट लिखा हुआ है ना, 3 तो नहीं लिखा हुआ। उसे 4, उसे लिखा हुआ 4 है, उसे बल्कि 3 and 4 अलाउ कर दिया है।
Because सर नीचे तो 3 पे भी सब्स्टिट्यूट हुआ है।
हाँ, इधर 4 लिखा हुआ है, फिर इधर 3 and 4 अलाउ सब्स्टिट्यूटेड प्रोडक्ट्स, फिर इधर ड्रॉ किया हुआ है
6 नहीं है।
कौन सा नहीं है?
6 नहीं है।
नहीं, 2 और 6 तो एक ही पोजीशन होते हैं। इसको इधर अटैच करो या उधर अटैच करो, इट्स द सेम थिंग। But 6 is not a different position, it's position number 2. Is that clear?
Wait, what was the original compound? वो 6 उस पे 4 पे नहीं था। 6 पे, sorry.
पता नहीं पेपर कहाँ गया, एक सेकेंड। हाँ, ओरिजिनल तो वो था, उस पे तो 1 पे था।
तो सर Q जो आइसोमर है, Q तो 2
2 पे
या 6 पे है ना, तो 4 पे क्यों अटैच नहीं है जो ने ड्रॉ किए हुए?
जो ये ड्रॉ किया हुआ है?
मार्क्स की मैंने एग्जैक्टली आई थिंक यही ड्रॉ किया है।
नहीं, मार्क्स की मैंने 3 पे ड्रॉ किया हुआ है। 3, इट्स अटैच्ड ऑन द थर्ड वन।
और वो जो फर्स्ट वाला ड्रॉ हुआ है,
हाँ, वो थर्ड पे ड्रॉ किया हुआ है ना, थर्ड पे, फर्स्ट सेकंड थर्ड। अच्छा, जो फर्स्ट, अच्छा फर्स्ट वाला, नहीं फर्स्ट वाले में ना व्हाट ही डिड वाज के ही ड्रू द अदर वन एज वेल, क्योंकि इट वाज बोथ वर पॉसिबल, एसाइलेशन एंड अल्काइलेशन वर बोथ पॉसिबल। मतलब ये था कि इसके दूसरे साइड पे यू हैव अ हैलोजन एल्केन, राइट? तो इट्स नॉट, क्योंकि कैटलिस्ट भी ऐड किया हुआ है, कैटलिस्ट दोनों में रिक्वायर्ड होता है। तो इन दिस केस इट्स अ हैलोजन, इट्स आई मीन ये वाला जो मॉलिक्यूल है ना, दिस वन, it's got 2 positive carbon atoms, right? I mean, this one is a halogenoalkane while this one is an acyl chloride. So alkylation and acylation are both possible. Either this carbon gets attached to it or this carbon gets attached to it. Do you get the point?
Okay.
नहीं वो गलत ड्रॉ हुआ मैंने उससे कहा है वैसे उससे क्वेश्चन में कहा है 3 4 दोनों अलाउ कर दो ठीक है he had specifically stated that allow 3 or 4 both ठीक है तो he had allowed both of them.
तो सर पोजीशन 4 पे अगर हम ड्रॉ करेंगे एग्जैक्टली ये विल इट बी रॉन्ग?
सही होगा ना उससे अलाउ किया हुआ है
ठीक है
पर उसने लिखा हुआ नहीं एग्जैक्टली के 4 substituted or 3 substituted or 3 and 4 substituted products. So that's it. Or diode try substituted products. ये अलाउ किया हुआ वो नहीं किया हुआ वैसे. So this one एक सेकेंड और कौन सा इस पे इसी पेपर में
5 for D and F2.
Draw the structure of Z in the box, right? So first thing is कि ये क्या चीज आके attach हुई है? Must be an okay, this is the halogenoalkane, so must be ammonia that's going to get attached over here. NH2 हो जाएगा, ठीक है? Right, with lone pairs. क्योंकि halogenoalkane, it's a halogenoalkane, not an acid chloride, ठीक है? So then this N gets attached to ये जो NH2 होगा, that's going to get attached to another halogenoalkane. वो Cl होगा ना, तो this carbon will be positive. तो ये वाला फिर इधर आके अटैच हो जाएगा. तो ये हो रहा है. Is that clear? क्योंकि हमने the only thing we've discussed, we studied about this is nucleophilic substitution. So the Cl first changes into amine, nucleophilic substitution. और फिर वो जो N है ना, that goes and attaches to the carbon in whatever this carbon chain is. It must be a halogenoalkane, तो वहां पे substitution होगी.
Sir, what about the O turning into OH?
अच्छा वो भी हो रहा है. हाँ जी फिर मसला है. फिर इधर ना acylation हो रही है. नहीं sorry. Amine बन गया. It will turn into an amide. How do I make it into an amide? I need to क्योंकि reduction भी हो रही है बीच में ना.
Sir, reducing agent से दोनों चीजें नहीं हो जाएंगी?
नहीं लेकिन मुझे यहाँ पे ना I have to somehow add an amide. Amide add नहीं reducing agent से कौन सी चीज हो जाएगी?
Reducing agent plus the alkyl chain, तो I think दोनों चीजें हो जाएंगी. O से OH और NH2 भी alkylamine बन जाएगा. I think so.
नहीं alkylamine reducing agent से होगा लेकिन amide चाहिए ना उसके लिए. So I can't have an amide with 3 carbon chains. Like how do I मतलब ये चीज जोड़नी है ना. तो halogenoalkane के साथ जोड़ना तो कोई मसला नहीं है. You have a Cl, you've got a carbon positive, ठीक है. तो ये तो 2 steps तो यही हो गए. So now how do I reduce it in the middle? ठीक है, that would need an extra step. तो काम तो हो गया लेकिन मसला है कि in 2 steps how do you reduce it? What if you amide ये बन नहीं सकता. I mean you can convert an amide to an amide as well because you can add a carboxylic acid. लेकिन for a carboxylic acid you can't have 3 chains because this carbon will not turn into a carboxylic acid. करना तो यही है लेकिन for the reduction part you need an extra step. इसका उधर से देखते हैं उससे क्या दिया हुआ है. Part D है इसी का.
D.
ये वाला है ना.
Yes sir, ऊपर है इसके conditions.
अच्छा उसने बहुत कुछ दिया हुआ है. First thing is acyl chloride's carbon C is more
नहीं
electro.
sir, part D.
Part ये नीचे वाला.
Yeah.
अच्छा ये उसने क्या हुआ है कि attach this in ethanol. अच्छा उससे अच्छा मैं ठीक है. मैंने एक्स्ट्रा स्टेप किया हुआ है. वो से एक ही स्टेप में कर लिया था. मैंने वैसे ही एक्स्ट्रा स्टेप कर लिया. He started off with an alkylamine. मतलब वो स्टार्ट ही आप अमोनिया ना करो, इट्स alkylamine. ठीक है. वो एक स्टेप उसी तरह कम हो जाता है. If you have an NH2 over here, तो क्या होगा? N के lone pairs होंगे. It's going to get attached to this carbon that's positive. तो एक ही
तो
स्टेप के
ये
साथ.
अभी भी nucleophilic substitution है.
हाँ
Okay.
वही है ना. N के lone pairs, ammonia amines, they will behave in exactly the same way. तो वो हो जाएगा. This thing will get attached to it and then you can reduce it. ठीक है. वो मैंने वैसे ही एक एक्स्ट्रा बीच में स्टेप डाल दिया था. But is this clear? The Cl gets knocked out, the N gets attached to this carbon atom. Is this clear?
Yes.
जिस पे और कौन सा?
Sir, F का part 2. I figured out 2 of these, but last वाली नहीं समझ आ रही थी.
इसके बारे में predict the number of peaks that would be seen in the carbon-30 NMR spectrum. Number of peaks that would be seen in the carbon-13 NMR spectrum.
Sir, it's part 2. No.
Part 2, the proton NMR spectrum of proton NMR. D2O shows peaks in 4 different types of proton NMR में OH चला गया. D2O में sorry. And NH2 is gone, right?
Yes.
Achha, the peak for the CH2N environment is a doublet in the chemical shift range. CH2N, where is CH2N? Ye wala. I mean, this is your CH2N, right? So this is 2 to 3. इस range में. And it's a doublet. जो कि ठीक है because the neighboring carbon atom has 1 H, right? Give the details for the other peaks in the proton NMR spectrum of include chemical shift values, value data booklet given and niche, yeah. Achha, other so the other ones are you've got CH3s,
CH3s.
3 CH3s, okay, that's all one. All of them are together. So alkyl chain CH3s जो होंगे वो कहाँ पे होता है? That's 0.9 to 1.7, right?
Yes.
फिर ये बीच में ना you've got a carbon which does not have H. तो वो चला गया उसमें, it won't show up. You've got a carbon with an H, this one. इसका तो एक H होगा ना. So this one would be इसके साथ neighborhood में ना there are 2 H's. So this one would be a triplet. Is that clear? ये clear है ना कि this one would be a triplet?
फिर neighbor में कितने H's हैं?
2 सिर्फ यहाँ पे क्योंकि ये वाला this carbon does not have an H.
Okay.
So this is going to be a triplet. Splitting pattern भी बताना था. This is going to be a singlet. फिर benzene रह गया पीछे. Benzene में क्या होगा? There's just H's over here.
Multiplet?
तो वो multiplet होगी and that's क्या range होगी? That's given over here. Alkyl next to
9, I think.
नहीं sorry, aromatic ring. नहीं, not attached. हाँ ये वाला attached to aromatic ring. That's 6 to 9. ठीक है तो सारे हो गए. Is that clear?
But sir, benzene में कितने protons will be responsible for this peak?
3, 4 है. 1, 2, 3, 4. क्योंकि दो जगहों पे तो H है ही नहीं.
Okay.
So there are 4 protons, 1 proton over here, 2 over here, and there are 9 protons over here.
All right.
ठीक है, चलो ठीक है, ये फिर नेक्स्ट टाइम डिस्कस करते हैं, ठीक है?
Okay, sir. Thank you.
ओके, ये मुझे क्वेश्चंस ना सारे भेज दो, जो भी क्वेश्चन है मैं व्हाट्सएप मी दोस क्वेश्चंस, उनकी मैं अलग से भी वीडियो बना के ना सेंड कर दूंगा, ठीक है?
Okay, sir. Thank you.
ओके, अल्लाह हाफिज़।